Welcome back. Good afternoon. We will continue the chemical bonding. In this now today we will see the valence bond theory. What is valence bond theory? We will see after 1 minute. But why valence bond theory? What is the problem with the Lewis approach, or what is the problem with the valency shell electron repel, electron pair repel theory, and all these things? Say Lewis approach could not say. Now you see a covalent bond between hydrogen. That means H2 molecule. If you see, this is H and H. One electron sharing by each and the covalent bond. Similarly, if you see the fluorine, fluorine also F covalent perfect. This is also diatomic molecule. This is also diatomic. Whereas here the bond enthalpy is different, bond length will be different. Here also is different from the F2. And the bond enthalpy, bond length, and all these things. Why? Why means it could not be explained by Lewis theory. Though they are able to tell something about the linear molecules and other shapes and all. Then comes to the VSEPR, that is the valence shell electron pair repulsion theory and all these things. It can give the up to p orbitals very nicely and all shapes, but it also afterwards it is failing. Then this valency bond theory and molecular bond theory is coming into the picture. If you see the valency bond theory, it is a very big theory that in the first year of the intermediate, very difficult to explain because atomic orbitals, overlapping of orbitals, hybridization of orbitals, then superimposition, similar things. But in prima facie, the small things like what is actually this. Suppose if you see the hydrogen, how it has formed. When both are at the far, there is no attraction. Hydrogen is having one electron, another hydrogen is having one electron. When they are far apart, there is no attraction between these two and there is no molecular formation. When both are coming closer to each other, interestingly, already nucleus of the hydrogen is having an attraction towards the electron. That's why this is in the shell and orbital. Similarly, for this another hydrogen also. But when they are closing to each other, at bond length, you see the potential curve, they are far. When it is coming to the closer to the bond angle, immediately the bond energy and the is less, and the bond, this is the most stable energy and all these things. So how is, suppose this is an attraction between this nucleus and electron, this one. But when it is coming closer, the nucleus of the other, suppose it is, you take B and A for the easy to recognize. This B is having more attraction on this electron, whereas A is having electron more attraction on this one than the repulsions of this both two. So that is why it is forming as H2 and the 1s2 electrons shape and all. Similarly for whatever is the diatomic and all. Similarly for the polyatomic and all whatever it is. Now coming to the shape. They could not explain, they could explain only some of these things, some of the shapes of the molecules they could not explain by the Lewis theory or valency shell electron pair repulsion theory and all these things. Now how it can be this thing? See, so here there are three varieties of this thing. One is no lone pair electrons, no lone pair electrons on central atom. This is one category on central atom. Second category is lone pair or one or more lone pair electrons on central atom. This is second category, central atom. Third category is lone pairs also there plus bond pairs also there. Bond pairs. These three pairs are there. So this Lewis theory and the valence electron theory and the valency shell electron repel theory, all it is holds good for the no lone pair electron on central atom it is. But whereas the others two it is deviating. Why it is? First we will see no lone pair atoms how it is. Suppose beryllium chloride. Beryllium, it is one chlorine in this side, another chlorine is it is a linear atom because there is no lone pair, because beryllium is atomic number of the 4 means only 2 electrons in the outshell, 1s2, 2s2, 2s2 means one electron is shared with this thing. This is chloride is having octet, This is not an octet, but it is in a linear. So similarly, mercury chloride or anything. This is barium chloride, beryllium chloride, and the mercury chloride type and all this thing. Next, this is there is no deviations and all. Boron trifluoride. Boron trifluoride. Boron is having a 5 means this is 1s2. Outermost is outermost is 3. That means 2s2 and 2p1. Total 3 outermost. So 3 it is a trigonal planar. A trigonal planar is like this. Here is the boron. This thing. And the fluorine and the fluorine octet. Fluorine is octet, and here it is not an octet. So it is a trigonal. There is no deviation. BF3 it is called trigonal planar. Here it is a linear. Next, if you see the methane or carbon tetrachloride NH4 plus or whatever it is, that is a tetrahedral. There is no deviation because carbon is outside the 6 electrons means total 1s2 after leaving 2s2 and 2p4 2s2 and 2p2, the total of 4 it is making with the 4 hydrogen atoms this thing. So it is a tetrahedral. Tetrahedral shapes are same. Then comes to the one by one we are increasing. It is a linear 2, it is a trigonal 3, here it is a tetrahedral 4, then penta is phosphorus pentachloride, that's a trigonal bipyramid, bipyramid. Then comes to the SF6, that is 6 electrons, octahedral. Then what is the problem? Problem is when one or more lone pairs on the central atom and no bond pair. That is the second level this thing. There is a deviation. That means what is expected through the theoretical this thing is not the same. Suppose again comes to a tin chloride or lead chloride. It is only 2. So if you see the central atom tin or lead, there is a lone pair, and one chlorine and another chlorine is acting octet here, but there is a lone pair. Because of this, it is supposed to be this one, what you call trigonal plane, but it is a bent shape, deviation. Similarly, if you see ammonia is NH3. It is similar to the BF3. Here BF3 boron trifluoride. Here I am writing as the ammonia. Ammonia also forming a 3, but ammonia is the 7, N is 7. So 1s2 is leaving. For there is a 5 means one lone pair is leaving. N, and there will be a 3 hydrogens. So it should be a trigonal tetrahedral, and but actually is a trigonal bipyramid. So here also again deviation. If you see the H2O, here now oxygen is having, so far only one lone pair we have seen. Here oxygen is having 2 lone pairs, and another 2, it is 2 electrons means out of the 8, first 2 are over, 6 out of 6, 2 lone pairs, 4 is over, another 2 electrons it is forming with each one with the hydrogen. So here it is supposed to be again a tetrahedral, but again it is a bent. So similarly, there are so many variations in this thing. Why? Because this is all because of the lone pairs, and one lone pair or 2 lone pairs. This is one category. What is the second category? The another category, if you see, that is again lone pair plus bond pair. One small example we will see. the lone pair and bond pair, ClF3, ClF3, a typical example. Chlorine and fluorine forming a compound, that too with this thing. So it is supposed to be a one lone pair, two lone pairs are there in the chlorine, two lone pairs, and another three are forming the two lone pairs, and this is a supposed to be a this shape, but it is a shape is a T shape. T shape. That means it is a lone pair also there. It is a forming a bonds also, bond pairs also there. So all these things are very well explained by the valence bond theory. So now we will see what is the orbital overlapping concept, or the atomic orbitals and the types of overlapping, that is sigma bonds, pi bonds, SS sigma, SP sigma, PP overlapping, all these things, hybridations and all. Tomorrow we'll see. Thank you.